Okay, we're going to be looking at problem number 71 on page 334 from chapter 6. This one is talking about a company that's making video cameras, and they make the video cameras in a few different varieties. They make basic model video cameras and deluxe model video cameras. And then when they sell these video cameras, they offer customers the chance to have a warranty. So I'm going to do W for the ones who buy the extended warranty, and W prime just means not W for those who do not buy the extended warranty. Then I'm going to have a column for total, both for the row and the column. I'm going to show you how you can use a table to set up conditional probability, and then at the end I'll work it through with a tree as well, for those of you who might prefer that method. Now what I'm going to do is I'm going to take, and it says over the past year 40% of the cameras have been the basic model. So I'm going to just assume that they have sold a total of 100 cameras, and that means that 40 of those 100 cameras have been the basic model and the other 60 have been the deluxe model. Then it says of those who buy the basic model, 30% get an extended warranty. So that would be not 30% of the 100, but 30% of those 40. So 30% of those 40.3 times 40 should be a number of 12. Now it also says 50% who get the deluxe model get the extended warranty, so 50% of those 60 who get the deluxe model should be a total of 30. Once again, that's the percentages not of the grand total, but of these totals I have over here for the basic and the deluxe model. Now, what it wants to know is it wants to know the probability that a purchaser bought an extended warranty. Wants to know the probability of them having the deluxe model. So the notation it's going to be looking for here is probability that they have a basic model given that they bought the extended warranty. The probability they have the basic model given that they have an extended warranty. So this is going to be equal to, probability is always what you're looking for compared to the total. So it's going to be the probability of B and D for your numerator, and then your denominator is going to be the probability of E, because you know for a fact that E has occurred, but you're looking for this numerator. You're looking for both B and D occurring given that that has occurred. So we go over here, and the number of times that B and E have occurred together would be given to us at this table right here, where it's a basic with the extended warranty would be 12, compared to the denominator would be the total number of times it had an extended warranty, which would be this 42 here. So it's 12 out of 42. Now remember as well, whenever you're doing a conditional probability, you can always just focus in on the part of the table you need, and since it's given that I have an extended warranty, I'm only going to look at the part of the table that has to do with the extended warranty right there. So basically I can ignore the rest of the table. I didn't even have a need to fill in the information for the warranty, but of course I could, if I needed to, get that information through subtraction. I could do 40 minus 12 and figure that out as 28, and that is 30, and then 100 minus 42 could have given me an answer of 58. But once again, I did not have to have that information for this particular problem, because all I needed was this one column to get my answer. I can also use a tree diagram if you don't prefer to use the table. If you're doing a tree diagram, you have to realize the first question is what kind of camera they get, whether they get the basic or the deluxe camera. And then you have to realize the second decision they make is whether they get the extended warranty or not. So once again, I'm going to use W prime to just mean they did not get the extended warranty. If you want to use E prime another letter, that will be just fine. Now I can fill in my probabilities. So the probability of getting a basic model was 40%. So that's going to be 0.4 going right on this little branch. And that means the probability of a deluxe model, since those branches have, every pair of branches has to add to 1, is 0.6. And once again, every set of branches does have to add to 1. Now, Then the probability of a basic warranty, given that I have the basic model, was 30%, so that's going to put a 0.3 on this branch. And although I did not have to have it on this particular problem, it would be perfectly acceptable to put the 0.7 on this branch. And then on this one, it's a 0.5. And that means the chance of not getting the warranty would be 0.5. Now, to get your leaves at the bottom of this, what I need to do is just multiply my way down the tree. So the leaves, I'm going to do them in orange down at the bottom. I'm just going to multiply my way down the tree. So 0.4 times 0.3 is 0.12. Just multiplying my way right down the tree. On this one, I would multiply 0.4 times 0.7, give me a 0.28 for that particular leaf. And this one here, I can multiply and get a 0.3. And then this one here, I could also get a 0.3. It is also true, if you do a tree diagram, that if you add up all the leaves of your tree, just like every pair of branches should add to 1, the sum of all of your leaves at the bottom of the tree should also add to 1. And in this case, of course, they do. Now, for the final answer, I still need to find the probability that I have a basic model, given that I bought the warranty. So my numerator would be this 0.12 right here for my numerator. And my denominator is going to be not only that number there, but also this number here, because both of these people represent I have the warranty. So the total number of people I have the warranty for is the 0.42. And once again, I have some decimals here since it's in terms of probability, but it's clearly the same answer I had the last time. And of course, you would either want to reduce that 12 over 42 or put it in your calculator to get a decimal, but hopefully that will help you understand how to do these conditional probabilities with a table or a tree.